So which is the displacement. If the core remains in null position itself without providing any movement, so what will happen now? Then the voltage induced in both the secondary windings will be equal. So which results in the net output will be equivalent to 0. Okay, so the thing is to be that if the core remains in null position, so what will happen? This without any movement over on it, the voltage which is induced in the two secondary windings will be equal. So that output will be equal to 0. And the next case, when you are saying about that, so external forces applied. So the thing is to be that if the steel iron core which tends to move in the left hand side direction, so then the EMF voltage induced in the secondary coil is greater when compared to the EMF induced in the secondary coil. Okay, that is the first value will be greater than the value of an secondary. Okay, so therefore the net output will be equivalent to the secondary voltage 1 minus your secondary voltage 2 over on it. Okay, and the next case 3, that is we have to apply the external force and the steel iron core will be moved in the right hand side direction. So what will happen now? Then the EMF induced in the secondary coil 2 is greater when compared to the EMF voltage induced in the secondary coil 1. So the output will be equivalent to secondary minus your secondary 1 over on it. Okay. So this is about an operations over here. So when you are saying about an operation, the thing is to be that when the core is at its null position, the flux linking with both the secondary windings is equal, and hence we'll have an equal EMF which is induced in them. So the net output voltage will be a 0 at null position. Similarly, if the core is moved to the left of the null position, more flux links with the L1, that is a secondary winding, and less with the secondary winding S2. So accordingly, the output voltage of secondary winding will be greater than the secondary voltage of your winding. Okay, the magnitude of output voltage is the E0 is equivalent to ES1 minus ES2, and we can say that it is in phase with primary voltage. Similarly, when the core is moved to the right of the null position, so the thing is to be that secondary winding voltage will be more than the value of a secondary winding voltage. Thus, the output voltage E0 is equivalent to ES1 minus ES2, and we will have of an 180 degree out of phase with the primary voltage. So the amount of voltage changes in either secondary winding is proportional to the amount of movement of the core. So hence we have an indication of amount of linear motion. So by noticing whether output voltage is increased or decreased, so we can determine the direction of motion over here. So when you are saying about the advantages of LVDT, actually we'll have an infinite resolution, we'll have a high output, the LVDT gives high sensitivity, so it will give a very good linearity, we'll have a rigidness, LVDT provides less friction, we'll have a low hysteresis, and apart from that, the LVDT gives low power consumption. So when you are saying about the disadvantages, so actually in advantages, the linearity will be good up to 5 mm of displacement, the output will be rather high, output voltage is stepless, and hence the resolution is very good. We'll have a high sensitivity, it does not load the measurement mechanically, it consumes low power and low resistance loss also. When you are saying about the disadvantage, it has a large threshold, it is affected by stray electromagnetic fields, so proper shielding of the device is necessary. The AC inputs will generate noise, so its sensitivity will be lower at higher temperature. Being a first order instrument, its dynamic response is not an instantaneous one. And when we are saying about an applications, so actually the thing is to be that it is used to measure displacement ranging from fraction of an millimeter to centimeter. So apart from that, it will act as a secondary transducer. Say the LVDT can be used as a device in order to measure force, weight, and pressure, etc. So the remaining thing that we can see in the next class.